Hello. How's it going, everybody? Okay. So, for those of you who are new to this stream, I'm going to be making a game on stream, and the source code is available via GitHub. So there's a link down at the bottom of the page here. So you should be able to get access to the code from the game by just pulling it down, even in real time, as I am producing it. So of course, if you're watching this afterwards on YouTube or something, then naturally that's not true. But hey, so let's take a look at where we're at. And this is a project I started yesterday. I'm about 2 hours in, and we're just going to be kind of making stuff. And I'll also be taking some suggestions from the audience of the stream on what to add to the game. I have no particular bias or interest in terms of what I think should go into this game, and so we'll just kind of do it. So right now we just have this character that can walk around using WASD. We've got some sort of squish animations on the character. We've got little berries, I suppose, and I spawned these out in the world so that there would be a frame of reference, so that once we start walking with the camera following the character, then you'll actually be able to see things moving around, so that you'll know where you're at. Put some bugs in it so we can fix them later. Don't worry, those will just come on their own. So it looks like probably the next natural move would be to get some kind of a camera in here that's going to follow the character, so that we can have the world be a little bit bigger. So I'm going to start working on that, and we'll go from there. Okay, so in the gameplay folder, I also blew up the interface of this a little bit. I noticed that on yesterday's stream it was a little bit too small, probably. So just let me know if you're having a hard time seeing things on the in the code and stuff. All right, so we're gonna make an object called OCamera, and we're just going to give the camera. For now, we'll just give it an instance target, and then in the step event, the camera can check if its target exists, and if it does, then it will move toward the instance target. And we're going to use the lerp function so that the camera, instead of moving robotically linearly, so that using the lerp function, it will trend toward the instance target. And then we will, after we move the camera object, we're going to set the GameMaker view position relative to where the camera object is. So essentially we have this object that's called camera that it itself follows and moves around and will go to wherever we tell it to go to. And then afterwards, it actually moves the viewport of GameMaker. So the question is, where should the view go? And it should go half screen left and half screen up from where the camera object is, so that the camera object itself is in the middle of the view. So we're going to move the view to, let's see, scripts, convenience. Do we have? We don't have a view width function, but there is this camera get view width. I'm going to make a convenience function for that, so that I don't need to type out this whole thing. We'll do the same thing for height. Okay, so now we will do this. Oops. And last, we will spawn the camera. and set its target to be the player. With instance create, so we'll spawn the character or the player at 0, 0, and we'll spawn the camera there as well. 0, 0 meaning just this. We'll treat this as the center of the world. Good morning, Zivix. All right, so with this is create camera, also at 0, 0, and we're gonna say instance target equals p. So you notice that I did this by hand, meaning the camera has this variable called instance target, and then here I'm saying instance target equals p. This is the kind of thing that you'd want to do with the script so that you don't forget this variable name or mistype it or whatever. So we'll do that in just a second. But first, let's just see if this works. Okay. So now we've got our camera object following the player around. Only took 7 lines of code. So and it's very smooth. You can see how it kind of drifts behind the player. For those of you who played Crashlands, you'd notice that if you start moving really fast in that game, if you start moving really fast in Crashlands, then you'll end up with the camera kind of lagging behind. And that's because of this smooth lerp function, where it closes 10% of the gap here at any given time. So we could, for example, we could set the lerp speed as a variable, and then we could later on, if we wanted to, we could change that based on certain things. Okay, and now let's make some. So we have our convenience functions. Now in our gameplay, we'll make a camera folder as well. And this will be for our camera object. Camera set target. And this will say instance target equals itarg. So this is a stand-in for what we just did. Up here in the gameplay controller, right here. So we're just going to say instance create camera, and then get rid of that. Camera set target p, which is, let me just turn this into a readable variable. Okay. So this should do the same thing, but now we can more easily set camera targets in other ways. And later on, we can also update our camera to be able to take multiple targets, and then it'll drift in between them, or you could even do like a Smash Bros. Style kind of camera zoom sort of a thing. Okay, so we have our camera. You should notice that if I walk too far in one direction, the berries will cease to exist, and now I'm just kind of floating in a void. So now I have no frame of reference of where I'm going, and it's also the case that so these berries are just sort of hand-coded. We just said, yeah, just spawn a couple hundred of them in a rectangle area. So this is not an endless world or anything. It's just a sort of pre-populated area. So I'm going to push this to the repo because we now have our camera. So for those of you who are pulling down the repo in real time, enjoy. You've got a camera now. All right. So there's a few things we could work on next. One is we could work on having some kind of enemies or something out in the world that you can interact with. We could make it so that, for example, you could like target a berry and do something to that. We could do some kind of world spawning. So if we wanted to make something kind of like, I don't know, kind of like Quadrupus Rampage, where you've got like a floating platforms in the world, we could try to do something like that. Or we could do more of an endless world, you know, kind of Crashland style. So I'm happy to take suggestions on what you guys would like to see. And if we do the Quadrupus Rampage style stuff, it's probably going to be a faster game to make, and that may be better since it is going to be a little bit more action oriented. So for starters, we're going to need a grid no matter what. So we're going to need to come up with what our grid looks like. So I think there's really no kind of right or wrong here when it comes to shooting lasers out of eyes to make berries explode and chaining explosions. And this game is called Berry Blaster. Yeah, the core mechanic is going to be combat, but it can kind of go. It kind of depends. So if part of the combat is, for example, like knocking things off of ledges, which was a big thing in Quadrupus Rampage, then you're probably going to want ledges to throw enemies off of. Shooting something, throwing grenades. A real violent crowd here. Okay. So let's think through our options here. I mean, since we have this beautiful character walking around, we have a camera, then essentially we're one step away from having a finished game, right? So, all right, so we could have enemies in combat. We could have world generation. Those are kind of the two. And with world generation, we could do like pre-generated levels or an open world. And with enemies, we'll mostly just need to figure out what is the combat like. How does that work? All right, what do we got here? We got grenades, shooting. We've got berries fighting back. Protect berries from bugs with a baseball bat. Add a garden section where you tend to plants so you can relax after all the violence. Okay. All right. We handled world serialization and deserialization. Okay. Probably the first thing to do, although I know you guys are pretty gung-ho about the enemies here. The first thing we're probably going to want is a place to, like a way to manage the enemies so that we can spawn them appropriately. So I'm going to probably do that first. So let's go with the pre-generated levels. Because I think if we want this to be a little bit more action-y, then that kind of lends itself a little bit better. So if you think about something, you know, Enter the Gungeon, Binding of Isaac, these kinds of games that have more pre-generated randomness to them in segments, it's a nice way to break the game apart. All right, so first we're going to set up some grid variables. So we have our grid width and our grid height. This is just the pixel size of the grid. And we're going to also want to give ourselves some conversion functions to sort of move between the grid and the world more easily. So, we'll have, for example, grid to X. And I typically use XG as shorthand for grid-based X position. Hey, Ronan Krang. So we could do an isometric grid. We'll do a simple rectangular grid for now, just because it's much easier to manage. Isometric grid or axonometric grid is the sort of diamond-shaped grid, and to calculate positions between grid and the world on that, you actually need both X and Y, and take them both into account. So we'll start with something simple. And if our grid conversion functions are good, then we should be able to actually just change to an axonometric grid at any time if we want to. All right, so we have X grid. We'll do a round function. So this is pretty simple, right? This is just, we've got our grid width, and so that means every grid space is going to be 100 more pixels. So we can now convert grid to X. We can do the same thing. Grid to Y. Y grid. And this will be based on the height. And then we will do the same, but the other direction. Let's see. Did I not get this? Okay, I got that. X to grid, X world. And now we have Y to grid, Y world, divided by grid. All right, so now we have some simple functions for easily converting back and forth between different grid spaces. So if we want to test this, first in our and for those of you who are kind of new to this to the idea of game programming or whatever, don't be afraid to just throw numbers out there and try them and just kind of see what happens, because you can always tweak things later. Programming is very flexible. It's not like painting, you know, where once you put the paint on the canvas, it's on there now. Okay, so we want to init grid. So remember, this is the script where we just established the grid width and the grid height. Let's also, just for safety, equals grid height. I like to set up a variable that is the ratio of grid height to grid width, because that becomes pretty useful later on when we're working on collisions and other things. Because you also notice that I can walk through those berries, and we probably want solid collisions, so we can look at that as well. All right, so we have our grid, and now in our gameplay controller, let's say berry spawn chance, maybe like 5% coverage, and now we're going to pre-spawn a whole bunch of berries across 100 by 100 grid space, and we'll see what that looks like. So this is 10,000 grid spaces that we're going to check right at the start. Okay, and now we're going to spawn it at, instead of these X spawn, Y spawn, we're just going to say grid to X and grid to Y. I love magic numbers when I'm testing. Although in this case, these are... Okay, so now we got 5% world coverage. So now we can go for quite a lot longer because now we're going 100 grid spaces in all directions. You notice that the berries are now lined up on the grid. So if we want to maybe see what the grid is really like, this is going to be a lot, but this will give us a... Alright, so we're seeing some lag here because we just spawned 10,000 berries. But this is how large our grid is. This is how many tiles there are in the world. Which is probably fine. We can potentially... And so you can see now if we want to change these things, we can easily shrink this down, maybe 50 by 25. So now we have a grid that is far more dense. Some would say too dense. They'd be right. So we'll start with this, and we'll see where that goes. Alright, so we don't want to spawn 1 trillion berries, necessarily. So I'm going to actually just nuke this code, because that was just there for us to kind of see where things were coming in. And instead, we're going to, well, I'll push this out, because we now have... Actually, let me go ahead and... I'll push it in a more stable state. Can you make the berries wiggle when you walk through them? Yeah, totally. Why do we make berries an object rather than a map or list? So that we can interact with them using collision and stuff like that. Right now they're just there as a placeholder. Okay, so we now have grid management code. Yeah, so what you're going to see a lot while I'm working on stuff is a lot of experimentation. So rather than trying to optimize, like saying, oh, we're going to have a lot of berries, I'm going to quickly like put all these into a grid just in case it's going to tank the FPS or something, I'll just do it the simplest way possible first, and then if it causes problems, then we'll go back and rework those systems. All right, so I'm going to go ahead and blow up these berries, and we're now going to make our world. So we know that our grid is 100 by 75. So I'm going to make some crappy sprites. Let's see. TL dirt. So we're just going to make a dirt tile that we can then place out in the world, and we'll treat that as solid ground. And this is going to be the same size as our grid. So you notice that as you go further and further into development, more and more things are going to become less flexible. So for example, if we wanted to change the grid size in level head, I could totally do that just with changing that single, grid size number. But all of the art assets are built around a certain grid size. And so we just can't do that. Is that dirt? Sure, that's dirt. And just for ease of readability, I'm going to put a single pixel border on this. So this is going to be a tile that I'm going to put out in the world. Let's see, stage generation. All right. All right, so stage generation is can be pretty involved. So we're gonna probably take this little bits at a time. So the idea that we're gonna try to do for stage generation is work on the next project. Next project is Levelhead, which is still in early access, and we'll be working on that for quite a lot longer. We still got plenty more things we want to put into that game. This game on stream is just something to do for fun on the weekends. All right, so for stage generation, we're going to want to create a system where we can generate rooms. A room is just a chunk of terrain floating in the world, and rooms are connected by hallways or bridges. So we can try to do this pretty simply first, and then we'll need to come up with a better way to track it a little bit later. So generate stage. Can you overlap tiles that are smaller to create a sense of depth? Yeah, what we typically do is use something called splash tiles, where we actually overlap the tiles quite a lot, and that kind of breaks up the pattern and stuff. So in this case, I'm just doing a direct one-to-one tile. But most of what I do in this game is going to be not super attractive, but we can modify things a little bit later. Okay, so to generate this stage, we're going to first just pick a random number of rooms. We'll say between 5 and 10 rooms. Minimum size of a room is, let me just go ahead and pull this in here. Also bear in mind I haven't done this in like 6 years, so there's going to be some flailing. All right, so the minimum room size, this is, we'll call this minimum room radius, actually. We'll do sort of circular rooms. Room minimum radius is going to be, I don't know, 3. So that would be 7 across if we count the center. Yeah, it's not game dev if there's no flailing. That is true. Most of what I do in my full-time work is stare at my screen and go, what? So let's see. So we have a certain number of rooms. Room centers X, room centers Y. So for now, I'm just going to store the X's and the Y's in separate lists. GameMaker does not have 2D vectors. So, although can you store an array in a list? Might be able to do that. If anybody knows, get back to me on that. All right, so we have, pretty sure you can. let's try it. Let's just try it and see what happens. Room centers, range, so we'll say is this a thing? So all this should do is just also always clean up your lists. If this works, then this would just put out a list of. Yep. You can put arrays into lists, so that's what we're going to do. So room centers is going to be XY coordinates of our rooms. You can update the array that is in the list without updating the list itself. Oh, right. Oh, that's interesting. Okay. Var, all right, so we have room centers, room start, x equals. So we're going to just start at the center of the world. Get rid of this. And get rid of that. So for now, let's just generate this room. So I want to make a circular room, but for now I'm just going to test out, just make a square room because it's easier. So this room width equals our random range. This room radius minus this room radius. See extra less than equal that. So we're gonna just make a big old rectangle and drop some tiles in the world and see how they look. Zivix, you're in the middle of a game jam? Yeah, GameMaker uses weak typing. Some would say the weakest of typing. Even like I made this list. If I were to just do this, like if I said show debug message room centers, all I would get is a number. Because a list actually gets an ID number, and the list itself needs to be accessed in different ways. So it's pretty. This does get kind of dangerous because if I made a dictionary like this, then these could actually both have the same ID number because lists and maps share ID assignment. And so if I did this, so you notice like if I do this, room lookup is a map, but I can call DSList destroy on it because they're both just numbers, which means this would succeed. Like this would be a successful operation and it wouldn't crash and it wouldn't throw an error. All that would happen is I destroyed the wrong data structure, and later on when I want to do something with room centers, then I can't, and now that's when I would get a crash. So this is pretty dangerous, and you'll get crashes downstream from that. Okay, so we're going to say, do the same thing here with our Y. Now what do we do? So we need to add sprites to the world. So we have layer add. So this is all pretty new compared to what it used to be. GameMaker used to have these things called tiles. And tiles don't exist anymore. Instead, you can just drop a sprite into a layer. Do we have strategies to deal with that? Yeah, I mean, it's very hard because of the fact that GameMaker sort of deliberately convolutes the difference between a list and a map because they share ID numbers. So even if you try to make safeguards for it, you still can't necessarily guarantee that you're doing the right thing. So instead, we try to make a lot of convenience functions to automatically clean up specific things, which we can get into a little bit later. Okay, so we've got layer stuff. I'm trying to find the function for setting a sprite in layer sprite create. And for now, we'll just make a thing called world layer. So this is all going to have to be cleaned up quite a bit later on. Okay, and we're going to put this at grid to x, grid to YYG, and the sprite is going to be YG, yeah. Sprite is going to be SPTL dirt. Let's double check our origin. Okay. So in theory, this will make a rectangle of dirt where the player is. But depth-wise, it's going to be all wrong because all the tiles are going to be at the same layer. So you notice how now I'm going through the dirt, which is all very silly. And actually, we could even... I'm going to make this a little bit more interesting. I'm going to make this 100 by 100. And I'm going to put a marker here. So at 75. I'm going to make it so that these have bottoms to them. Let's go a little bit darker even. This is gonna be the idea of like having floating tiles in the world. And now I'm gonna go 50 in and 37 from the top, which was our original origin. Make a farming game. All right, so what do you see here? Are you guys picking up on this? Looks like a weird stair-step thing. So why would that be? It's because we're spawning from the top to the bottom. Or I guess the other way. Let's see. Room start YG. Bottom to top. So if we flipped this around, would we see it go the other way? No. Greater than. Okay. And I'm going to remove this green and swap out the backdrop with something something cooler. Let's get Inkscape up so we can find some colors. So if we really want to make something quadrupus-like, then we should just go ahead and put this in the ocean. So we'll want some deep blues, and we'll go lighter at the top than at the bottom to kind of create that feeling of depth. A little more blue. All right, that should do for now. Again, since this is all placeholder stuff, this is really just more about trying to figure out the vibe of the game. I may end up doing a stream where I just make a bunch of medium to low quality art. All right, so what do we got here? We got 31, 59, 110. 59, 110, is that right? Yeah. And then the bottom is 18, 12, 43. Yeah, so don't worry about me going through the ground. It's just a thing that I do, you know? Okay. And let's also make a detritus layer that moves with the camera so that we can get a better feeling of there being some kind of depth. So, just that I'm not being blinded, as you guys have noted, it's going to make this thing full screen. And this will be a full screen. Actually, I'll just make this black for now. So I'm just going to make a simple overlay that basically has sort of like pieces of, I don't know, ocean debris in it. Add going through the ground as a mechanic. Yes, you got to get that StarCraft vibe. I just got the cartoon pack for StarCraft. That was pretty incredible. If you guys aren't familiar, there's a YouTube channel called Carbot Animations that does a bunch of Blizzard themed stuff, and he got hired by Blizzard to make a full reskin of StarCraft. You can play StarCraft in like goofy cartoon graphics. Okay, so we're just putting these in here. And I'm using the spray tool in Inkscape because it's it creates clones, and clones then it's like if I do this, then now it cascades out across the whole thing. So if I need to change something about this, then I can. So I'm just going to create this layer and knock the opacity down. I think this should probably be dark, deep blue. So let's try that. Export this just to the desktop. Detritus. So there it is. You notice it's just kind of some blue dots. Really just going for atmosphere. so in the world background, we're now going to, so we have our full screen color, and then we're going to draw sprite tiled. We have got to name this thing SPBG detritus. So then 0, and we're going to put this at view center X, view Y, detritus, speed, or we'll call this camera influence. So all this is going to do is it's going to have the detritus move with the camera, and it's going to do so in a way that is only 50% influenced. So as we walk around, then we'll see it moving, but it'll... Okay, so you see it back there. Very nice. And we want it to be moving for starters. Yeah, it definitely should probably just be black, now that I'm looking at that. I think that blue really... it's doing too much. Notice how it feels dark at the top and light at the bottom, because of course color is relative. So we really want it to just kind of darken what's going on back there. So let's do this instead. All right. So this will look a little bit different. Have you guys seen those color optical illusions where they're like, what color is this? And you're like, it's white. And then they move something and you're like, oh crap, that was orange. Okay, so now we've got our detritus back there doing okay work. We do have that kind of feeling of depth, which is nice. I think we can do a couple of things here. We could probably scale this stuff down. Actually, let's scale it down in Inkscape first. Just like that. So that it's not quite so overwhelming. Then we should do 2 layers, and we should make it kind of drift. So that it creates that feeling of that we're kind of floating in the sea or whatever. Okay. Port. Don't worry about my giant spaceship. It's no big deal. Okay, so we're going to draw the detritus. We could actually... speed is going to be... We could also make it kind of move in a wave pattern. But first, let's do this. Equals 0.5 and 0.9, 0.5. Make a couple of layers. Scale, scale. And we'll adjust these as we go. Okay, so what do you see? So this feels weird, right? Because the one in the back is barely moving, which makes it feel really big, but also they line up perfectly, right? So, easy way to break this apart is just flip one of them. Pretty sure GameMaker can handle that. But I don't remember. If not, we'll just scale it down, which I think we're going to do anyways. So, alright, that appears to have broken. I guess negative scaling is no good. So we'll just do scales. 0.5 and 1, maybe even. So the idea here is, to give a little more clarity of what I'm doing, is I've got two layers. One is being influenced by the camera at 90%, which means if the camera moves 100 pixels, that background moves 90 pixels. So what this does is it creates the feeling of it being far away, which sounds weird because you think like, oh, it's moving with the camera. That means it's close, right? But if you think about when you are like driving down a road or something like that, and how as you look out the window, you see things further away, and they just kind of like stay in your field of view the whole time as you're driving. So think of like a cloud or, you know, a mountain far away or something. So you just see those things longer even though you're moving super fast. So the same thing applies here. Meanwhile, these tiles on the ground have 0% influence from the camera. So they're not getting anything at all. Okay, so this is feeling better. And the last thing is, you notice how the background is pretty static, right? Like if I stop moving, it's just sitting there. And we want to create a stronger feeling of movement from this. So we will. I think a good way to do this would be to have detritus X, detritus Y, and we can move them like waves. So first we'll just move them normally. Detritus X and detritus Y. Plus, and we can also multiply that by this whole thing by camera influence, so that if it's farther back, it's not moving quite as much. So we want these to kind of drift. So for now, we'll just say 100, 100. We'll just move at an angle. And it should be affected by slow motion, which we covered last time. So we have this slow-mo seconds. Boop, boop, boop. What do we do here? Background draw, line 6. Yeah, that's not gonna work. Gotta put that inside. Okay, so now we are moving very fast, feels like. This is too much. But while we're in here, so for starters, I think, is that directionality kind of weird? I don't know, we'll find out. All right, so we're gonna say our detritus x speed. Let's actually put a sine wave on it. Temp sine. We'll just do the same thing on both. So what this is going to do is it's going to make kind of a wave feeling. But it's not very noticeable because it's moving too slowly. So if we really speed it up, then you'll see... If something's not noticeable, always multiply by 10, right? Notice how it's kind of like jerking around. Which is not what we want. And also... This is backwards, okay. So... 40-40. Just kind of keep playing around with the numbers until it feels the way that we want. Got it. Okay. Got a couple things backwards here. This is going to sound weird, but I need to influence the camera position by... I need to influence the position of the detritus by camera influence, and I need to modify the X position by 1 minus the camera influence. So it's just kind of feeling a little bit weird. Okay. That's pretty good. And let's just tweak the Y speed down just a little bit, and then we'll call this good for now. So that things are moving a little bit more horizontally. All right, so we have our moving background, and we have our terrain that we can fall through. So we'll push this out. All right, let's get back to terrain generation. We'll worry about that depth problem in a little bit. Okay, so what we've done here is we are creating a room by just dropping a bunch of layers down. So I'm going to turn this into a script, and over time we're going to actually move several of these things into scripts. Stage room. And this is going to require several arguments. And our generate stage function is going to rely on this generate stage room. So we'll say room center, xg and yg. Room radius, 2. And let's go ahead and put these all on a global layer. And layers are specific to rooms, which means in the generate stage function, we're going to need to create that layer. Layer create. We'll put it a little farther back now. And here we will replace this code with our generate stage room code. Put this in the world layer, and we need our arguments. So we'll get rid of this. Radius is this room radius. All right, so just for safety, let's check and make sure this is still doing what it's supposed to do. So I'm not having the depth problem because I just pushed everything further back. And later on what we'll do is we'll be storing all of these world positions in a grid so that, or a DS map, so that as I'm walking around, I can't walk off the edge. So right now, of course, this is just visual. There's nothing actually mechanical happening here. Let's generate several rooms. And we'll say rooms. Room XG. So we're going to start here, and then after we generate this room, we will just pick a new location and spawn another one. About the shadow will also have to look for whether we're standing on solid ground. So essentially what we're going to do is, first we're going to generate a bunch of terrain, and then on that terrain, we're going to decide whether to generate enemies or environment objects, and then we can kind of bias that based on whether something is an edge or whatever. So we can change the visuals of it and change the mechanics of it. Okay, so we're going to generate this room, and then we're going to so we have the current room radius, get the new room radius, and we're going to figure out the distance from our current room. There's going to be a lot of issues here, but that's okay. We will work them out over time. So the room distance is going to be, for now, we'll just say room radius plus new room radius plus so we're going to essentially pick how big the new room is. We're going to spread the rooms apart, and then we're going to pick how along the bridge is, and then we'll go back through this. So room centers, room center equals room radius, new room radius, and we need to update the location as well. XG equals and also you could do this in any order you want. You know, you could like set all the info first, then generate the room, then set the next info. Doesn't particularly matter. Whatever's most understandable for you. So the new room radius, new room center is going to be, let's see. Since we have to modify both, let's keep it preserved. Oh yeah, we need direction too. Direction equals any direction we want. Length dir x, room distance. Clarity here. Long variable name, but makes sense. And the new room YG will be the same. There's one problem with this, which is that this is going to give us decimal values, and our grid is not decimal, it's only integers. So we're going to round this whole thing. And actually, we can just go ahead and do this. Okay. And that should do it. That should give us some number of rooms, right? Or I've messed it up and we're stuck in an infinite while loop. Okay, so you're noticing what? Because these rooms are rectangular, they're going to overlap a lot. And also because we're not checking for existing rooms, then they're going to overlap in that case as well. So we do have sort of a arena-shaped area, but it's not obeying any rules in a coherent way that we care about. Just to see, what if we really spread them out? What do we get? So you're seeing a lot more space in between. So by customizing these numbers, then we can also modify those numbers stage by stage. So we could actually change the min and the max room size, or change the min and the max bridge lengths, so that sometimes you go into a stage and you'll see it really spread out, and other times it'll be very compact. So let's keep that. I'm going to push this out. Okay, so we're working our way toward there. And I'm just committing here because this, although this does have problems, it is stable and it's getting us closer to where we need to go. So we can always revert back to this if we have to. Okay. So next, what I'd like to do is update our room to be circular. So I'm going to do that. And the easiest way to do it is just make a DS grid, which is just a simple data structure. And width is going to be radius times 2 plus 1. The plus 1 is so that we have a central grid space. Okay, and we can clear the grid with zeros. And then you can just do dsgrid set disk, which will be, it just iterates over the grid, and it'll anything that's within a circle will just be set to whatever you need. Caliber Banks, how's it going? Things are good. Room radius. Yeah, I think that's right. Okay, so we're just gonna basically create a grid, punch out a disk in the middle, and then that's what we're gonna use. Okay, and then we need to, let's see, center the disk in the world. So I'm gonna leave this here just for reference. Take this. We're gonna start at 0. We're gonna go less than the width of the grid. Same thing with the Y. So one thing that happened when we were working on Quadrupus Rampage a long time ago is we just stored all of these values in an array. So we would generate the world and put all the information about where tiles go and stuff into an array of a fixed size. What you'd notice is early game, there's a lot of holes in the ground and things are, and things are a little bit more sort of varied and interesting. And as you go further in the game, you end up fighting mostly on just like a giant square, like just a big square patch of ground. And that's because at a certain point, we just kind of filled up the array and just never really got around to going back and solving that. So what I'd like to make here is a room generation system that is independent of having a box around it. And it can be as sprawling as we want it to be. So the stages can just keep going as we want. Okay, so we're iterating over this grid. This grid space value dsgrid get room grid. Okay. So what we done is we cleared the grid, filled it with zeros. We set a disk of ones in the middle of the grid. Now we can just check the value here. So if we are within that disk, actually, you know what? I'm not even going to do this. There's a simpler way. Simpler. Ready for this? If point distance of this position is there. Got it in 1. Sometimes you got to do things the dumb way before you do them a less dumb way. So this is just saying, hey, as we're iterating over the room, are we within the radius? Yeah, okay, then that's going to make a disk shape. Cool. Oh yeah, I got to get rid of this grid. What am I doing? Get out of here. All this stuff. Ooh. Circular rooms that are all sitting on top of each other. And you know, for safety, I'm going to these berries are really coming in handy. I'm going to put a berry in the middle of each room so I can actually see where these rooms are. berry. Look at these berries. Okay, so this will allow us to actually just see our room centers. Now you might be looking at this and you're thinking like, hey, all these rooms are just circles. Isn't that dumb and boring? Yes. We gotta start somewhere. Do we care that they overlap? We might not. Kind of depends. So if they overlap, that might just end up creating some interesting scenarios. So for example, if we treat the center of the room as a place to spawn maybe like a treasure chest or a pickup or even like a boss or something, then if the rooms overlap each other, then you might end up in scenarios where you've got like a couple interesting things happening in proximity to each other. So it might just be a non-issue. Okay, so we've got that. And I'm going to move that world layer back even farther. To like, let's see. Did I even initialize this? I don't think I did. It's only working because we set that variable in the gameplay controller. Generate stage. World layer. So we can put that 50,000 back. So we have our background depth and our shadow depth. 100,000. Shadow depth can be 40,000. And actually, we could probably just keep them all flat on one layer. Since this isn't an infinite open world, then we can just set these things to fixed depths, and just as long as they're far back enough that they don't cause any problems, we're good. So let's see, let's go to our background. So our background in the step event, we no longer need to do these things. We can just straight up set it to that. And shadow draw as well. And I'm going to include the terrain depth in here as well, so that we make sure that we keep it all in one place. This really doesn't need to be that far back. Okay. Terrain depth, shadow depth, background depth. Stage room, generate stage, terrain depth. All right, just for safety, let's check. So what we have to do with the things that are moving around is they need to set their own depth based on their Y position. So we just need to make sure that everything in the terrain and stuff is far enough back that we won't end up going through it eventually. Okay, and you also notice we're getting the same results every time, and that's because GameMaker uses the same random seed whenever you boot it up. So all we got to do is in our initializer object, just need to run this randomize, which I believe will set the seed somehow associated with your system clock, which is nice because it changes all the time. You don't have to worry about it. All right, we're getting there. Let's push this. That's true, Caliber. Assuming we can change the depth of a layer midstream, which I think we can. All right, so we now have rounded rooms and randomized seed. All right, so where are we at? We've got rooms being generated, but they're all totally circular, and they also aren't connected to each other. So the first thing we're probably going to want to do is, let's see, terrain edge list. We're going to need to start storing information about the terrain so that we can iterate over it. So no more of this. Generate stage room. Yeah, a fixed seed is definitely nice for debugging. But it does kind of put your blinders on, because what you're debugging now is one version of your random generation. So you got to make sure you're always aware of that. Okay, so when we first start generating the stage, clear our room centers list. Okay, so maybe the first thing to do is create these bridge connections, right? So I'm going to, let's see, what do we want to do here? We want to essentially denote different types of terrain in different locations, and then iterate over them and update them. So we have different edges, different maybe terrain for bridges, and that kind of thing. So it'll be the best way to do this. All right, so I'm going to do something that's kind of badly optimized, but we can go back and fix it later. So I need to basically have a lookup system where I can store information about the world. And the issue is with GameMaker, I'm not going to be able to use a 1D array as a key in a map to look things up. So I need to basically convert a combination of X and Y grid spaces to a coordinate pair, and I also need to be able to do that the other direction. So one way to do that is to simply turn an X and Y grid into a string, slap a comment in the middle, and now I've got a single string that's unique to that grid space. I could also then reverse it like this. Bar, let's see, comma location, string pos, that in the coordinate. So I'm doing this the bad way, and then we could potentially talk about how to do this in binary, you know, if people want. All right, comma location is going to be that, and then we're going to equals string delete comma location, and we can just do this. So this will pull the first part out by deleting everything starting at the comma location, and then the Y grid is going to be starting at position 1 up through comma location plus 1 equals location, YG location. I have to convert those to reals. All right, so this is one way to do it. I think these counts are right. This is a lot of type conversions, and GameMaker is also pretty slow with dealing with strings. So let's just debug this real quick and see if this is working. We can just do it in our initializer object. Let's see, XX, or let's say XG equals 480, 129. And let's turn it into a grid. And let's convert it back. And we'll output all of it. Also going to get my... I haven't had to do a lot of debug logging yet. So we're going to say some debug convenience functions and the echo function. So all I'm going to do for this echo function is allow you to pass in any number of arguments, turn them all into one string, and then print them to the console. So you don't have to type show debug message and then pluses and concatenating strings all over the place. Plus equals string argument I. Is that. Okay, so now we have our echo function. So we can say this, and we should end up with the same thing. I guess we can just echo XY straight out. And let's echo the coordinate as well. .480, 129, 480, 129, 480, 29. So it looks like we chopped off one, Y grid location, comma location, start at, comma. No. End at the comma, yeah. Do it 480, 129. Okay, so that is the slow way to convert grid coordinates. Do you guys want to see the binary way, the fast way? That's much better. All right, I'm going to take your silence as a yes on this. Here we go. Okay. Those of you guys watching, How much do you know about binary encoding and decoding? Yes, Shamus. All right. So, binary is super cool because it means nothing. All right. So you may see people being like, "Oh yeah, here's some binary code." Blah blah blah. So this is this 8? Is that? No, that's 9. 8. No. Yes. All right. So binary is basically taking a sequence of 8 ones and zeros and then using it to convey information. However, if I gave you this, like this chunk of ones and zeros, and I asked you, what does this mean in binary? Your answer should be absolutely nothing, because I need to know what you want me to turn it into. So you can essentially read this as whatever you want. You can try to read it as a string, in which case your computer will, try to turn this into a character. You could try to read it as an integer. You could try to read it as a signed integer, meaning this first 0 will be treated as a negative sign instead of as a number. You can do all kinds of stuff with this, but by itself it means nothing, and essentially it all comes down to you telling your computer how to read this thing. So we can actually use this trick to, so we have our grid buffer here, and a buffer is just it's basically just a container that holds binary, just pure binary data. So I've created a 4-byte buffer, and that's all the size that it has. And what we're going to do with our coordinates is we're going to take 2 16-bit integers that are signed, and these are our grid coordinates. We're going to write them into the buffer. Okay. And then what we can do is we can read them back out. So first we could just we can encode the buffer as a base 64 encoding, which turns it into a string. So, and then if we want to read it back out, we can base 64 decode the buffer. Alternatively, we could take these 2 S16-bit integers, write them into the buffer, and then you could read them back out as a 32-bit integer. Right? Because remember, binary, it only has meaning based on what you tell the computer to do with it. So I could take 2 numbers, fill up a 32-bit integer, meaning it takes all 4 bytes in the buffer, and then that just becomes 1 number because I just tell the computer, you know what, just treat this as 1 number. So you can kind of do whatever you want with it. So I believe it was the case that potentially reading out 32-bit integers would maybe break some stuff in GameMaker, but we're gonna try some stuff anyways. So okay, so we have our buffer, and we're gonna say grid to coordinate. All right, so instead of this, we are going to first go to the start of our buffer. So the way that you handle buffers in GameMaker is you basically just go to a position in the buffer, and then you can read the binary in there however you want. So I want to go to the start of this buffer. I want to write, let's see, buffer S16. So all this is saying is I go to the start of the buffer. I'm going to treat my grid spaces as signed 16-bit integers, which means they go up to and down, like, so they go from negative 32,000 to positive 32,000, which is plenty of numbers available. I'm going to take that, write it in the buffer, and then I could, for example, do this. Let's see, base 64 encode, grid buffer, offset 0, size. I guess we already know it's 4, so we'll just hard code that. And we'll go back to the beginning of the buffer. Okay. So base 64 encoding is essentially taking this binary blob and turning it into a string. And this is, you can see this happening on the web oftentimes. People are sending text data over the web that needs more information in it. They can just base 64 encode it. So if we want to turn a coord into a grid space, so we have our coordinate. So instead of all this string crap, buffer base 64 decode ext. So now we can essentially so this will take the base 64 encoded data and it'll put it right back into our buffer. Coord offset 0. And now we can read it back out. Let's see, buffer seek. I know this is pretty mind-bending. It took me a really long time to get a feel for how all this stuff works, because when you're early in your programming, you think about things in a very concrete way, like a number is a number, a string is a string, a list is a list, an array is an array, all that stuff. But as you kind of get deeper into it, you realize that none of these things really mean anything. It's just the computer reading things a certain way. And so once you start being able to dictate the terms of how the computer reads stuff, then you can really start to play around with all this binary stuff. All right, so we're going to go to the start of this buffer. We're going to get rid of this string stuff. Buffer read. Okay, and so if we say real here, one interesting thing about GameMaker reading things out in binary is that they stay in this sort of non-standard data type, and for GameMaker to do specific operations with numbers, they need to be in this real format. So if you read a number out of a buffer, you're going to want to probably convert it into a real. So, all right. So let's see. See you, Caliber. Thanks for stopping by. All right, let's see if this does what we need it to do. All right, so I don't know if you guys can see down here. We have 480, 129 was our grid. Our coordinate becomes this weird looking thing. We wrote this into a buffer. Can you step through the buffer in the debugger and show what's actually there? Actually, I think we can. So in our debugger, let's see. We want to open up variables, grid buffer, view as add watch, grid buffer. Now there is a way to look inside of a buffer directly, but I can't quite remember. Oh, here we go. Other buffers, buffer ID, 0, which is that one. So when you look at it, it's going to look like nonsense because, again, it all comes down to what you're reading. So this is being converted. So this is like 2 characters represents one byte. So we had a 4-byte buffer. So there's another interesting way to do this, which is you could just say real grid buffer S32. So here's an option. Chord to grid. So all we're doing is, instead of this base64 encoding and decoding, this may not work depending on how GameMaker likes it, but all we're doing is we're saying write 2 numbers in to those 4 slots as S16s, so signed 16-bit integers. Hey, Mind Skills, thanks for coming by. So we're going to write 2 numbers in and then read them out as 1 number. So we'll try that and see what that does. Okay, so same thing. So 480 and 129 becomes 8,454,624. And then if we read them back out by splitting it down the middle in binary, it once again becomes 480, 129. I'm going to go with the base64 encoding method, though, because when we're storing things in a DS map, it's better to have strings as your keys. So we'll just do this. Okay, so we have our coordinate system. And that was all, hopefully that wasn't too elaborate, but the basic idea here is we need an easy way to store information about all of these different spaces in the world. So whether there's like a piece of terrain or an item or an enemy or whatever, and without a good way to convert world coordinates into a key, then that becomes very difficult. So I'm going to, let me just double check that this still works. I'll push this out. Down, scroll down. 480, 129. This is our key, so we're good. We can now convert pairs of coordinates into a lookup key using binary. This was to get a key to represent coordinates. Yep. So you could just do it in that, if the binary stuff is overwhelming, you could just do it that first way that I showed, which is just take the X and the Y, slap a comma between them and treat them as a string, and then, you know, take the comma out and separate the numbers out later. It's just the case that performing string operations is generally going to be a lot slower than just dealing with straight binary. So, okay, so we have our world. So we're going to go back to our stage generation. And we've got a couple of options here. So first we have, let's see, generate stage room. So you notice how when we generate our room, we actually aren't storing really much information about this room. All we're storing is the center of the room, and then we're just creating tiles straight up. So maybe instead of doing that, we should say stage generation, global, so terrain locations. My fingers get tangled. Okay. So the first thing we're going to do is when we generate a room, we're actually not going to put this sprite down. Instead, we're going to add this location to a list. This position coordinates equals grid to chord. Okay, so you guys seeing what I'm doing here? So we were taking this thing and just making a sprite. Now we are converting those into coordinates. We're going to store those, and once we're done with everything, then we will spawn the tiles. So this way we can modify the terrain and do things like fray the edges and all that stuff. Then we spawn the visuals on top. Then we also want to say terrain types, this position chords. So if we haven't already, set up this terrain, then we'll go ahead and do it. And you might be asking, what's a terrain type? I don't know yet. Presumably it's going to be like an edge or an interior or something. So maybe we can quickly set that up. So this could be a macro. It could also just be an enum. Let's see, terrain type. Oops, interior and edge. Type dot interior. What happened with that space game I was working on? Zialk asks. So that was, I decided it'd probably be more useful to people if I could work on a project completely from scratch and make the source code available. The space game actually carried with it a lot of pre-built stuff from our studio that I wouldn't necessarily be comfortable just giving away. So this way on stream I can just make everything and then give it to people so that you guys can have the code and use it for whatever you want without any worry about any kind of copyright issues and stuff. So this way it can be much more of a community service. So there's a link to the GitHub repo down at the bottom of the stream description. Okay, so we're going to add so you might be saying, how come I'm adding to a map and a list? Like, what's that about? Great question. It's because maps, we're going to have a lot of pieces of terrain. And iterating over a list is dramatically faster than iterating over a map. So I'm going to use this map to just look up and store information about the terrain. And I'm going to use this list to actually like hold just a list of locations. So we can easily iterate over that list and take care of things. What mic? This is a Samson Meteor mic. It's pretty good. It's about an $80 mic or so. You just got to make sure it's pretty close to your face. As with most decent mics. All right, so we've got our generate stage. So notice I removed the spawning of the terrain from this, and instead we're just storing the locations of the terrain. So I'm going to go back into my generate stage, and now we're going to iterate over all those locations. So we're going to break this up into parts here. Let's have the locations of the rooms. Spawn the visuals. I'd say I'm about 6 to 8 inches away from the mic. It's like right here. It's just off screen. All right, DSL size, terrain, locations. All right, so we have these locations. Remember, these are stored in grid coordinates. So we're going to want to convert it back. We're going to convert this XY just like that. And this should get us right where we were before, which is, so now when we generate each room, we are storing the type of terrain and the location. And then we are afterwards spawning. Okay, so we still have terrain being spawned, which means it's working. But you may notice, so we have this, when they overlap, they create this, you know, this sort of weird nonsense going on. So all I'm going to do is I'm going to sort them by their Y location. So here's how we're going to do that. Spawn order. DS priority create. Okay, so we have the XY, DS priority add. We're going to add to the spawn order this coordinate, and the priority is going to be the so a DS priority is a game maker data structure that is auto-sorted. So now instead of iterating over the list, I'm going to just go through the priority. Let's see. Priority, delete min. Do we still use Inkscape for graphics? Heck yes, we do. So DS priority delete min will delete the smallest priority thing, and it will return the value, or the lookup. So should be able to do this. I might have done it backwards. Find out. Backwards. Easy. Swap this out. Delete max. Okay, so you notice now, even if these things overlap, then it's fine. We don't actually have any kind of weird depth sorting problems here. So that's pretty cool. Okay, now, what if we want to add a little bit of variety to this? What if we just kind of jiggle these things around a little bit? So when we spawn these pieces of terrain, just give them some random movement. Ew. Kind of a broken up looking world here. You can now kind of see cracks through there, which is something. Probably what we'll do next stream is maybe convert this to isometric, so you get that real quadrupus vibe. And let's, last but not least, if they moved when you stepped on them, we could do that. With programming, you can do anything. There's sprite, set. There's sprite. I want to do blend. Blend. Alright. I'm going to make another function here. Drawing. Color. Darken. Alright. So this is just going to say you want to maybe darken some of those tiles a little bit so that they just have a little bit more visual variety in them. So you guys want to see the blocks moving when stuff happens, huh? Alright, if you come to next stream, we'll do it. You gotta hold me accountable though, because I might just wander off and do something else on stream. Alright, so the color, we're gonna start with the color. I guess color. So notice how the Yo-Yo Games team sometimes use the American spelling and sometimes the English spelling of color. We're going to change brightness here. RGB. I'll do the real function. So it's more reusable. 2 beards and a microphone. Hey, how's it going? Yeah, this project is just for stream. This isn't a commercial thing. It's mostly just to kind of give back to the game dev community and teach some people some stuff. And I'll probably learn a bunch of stuff too, because, you know, it's hard to do stuff and not learn, right? So we're going to simply tint this, and we have to clamp it. Okay, so this is just going to allow us to darken any color that we want, so that when we generate our stage, we have this, and then we can just say, let's darken. Ooh, yeah, I missed an argument here. Are we working on another game? We're still level. We are full-time on Levelhead, 100% until post-Levelhead launch. Color darken. All right, so we're going to darken, let's see. We're going to start with white. And then we can just kind of go like down to a 7% darkening. Levelhead's out in early access, so we are still working on it for probably another half year at least. Okay, so we have a little bit of now visual variety on these, kind of enough to make it less boring, which is nice. Yeah, so right now we're keeping Levelhead in a pretty constrained capacity, so we're not marketing it super hard, and we are only keeping it on Steam Windows for now. So when we go to full launch, then we'll bring it out to a lot more platforms and do a big marketing push on it. So, okay, so this is pretty decent. So I know it's technically stream end, but I want to do a few more things, if you guys don't mind. All right. So we now have spawning our visuals. We have our terrain locations. Okay. Opinion on porting from GameMaker to Switch? It's fine. It's not really... It's not too complicated. I think as with many console ports, it just comes down to getting through cert. Which isn't really a platform thing. It's just you got to submit it, and then the company, you know, Nintendo or Microsoft or whoever it is that you're submitting to for console, they'll review it, and it's a lot more of a rigorous process. All right, so I think one last thing I want to try to do is detect edges so we can get some visual variety here. So we're going to make an edge tile that it's going to be more of like a rocky thing. Okay. So this is our edge. And when we generate the stage, all we need to do is iterate through our terrain locations, look around each piece of terrain, and if there is open air around it, then it's an edge. And at that time, then we replace its entry in the map, and then when we spawn it, we read that out, and then we spawn a different tile there. So with the coordinate, we have our XY, and say our I is the XG, XY. So we just look in a square around this piece, and we swap it out if we have to. Oops. And that's wrong. Okay. +1. All right, so we've converted our coordinate location to a grid array. And we are now looking in the nine tiles in that area. So, let's see, coordinate to check is grid to coord. So you can see why being able to easily convert grid spaces into some kind of a lookup key is super useful. Terrain types. All right, so if there's nothing here, then that means there's no terrain there. So, that means we're in open air. So, or I should say, var is edge is false, and we can add this in our check so that we can abort if we need to. Okay, is edge equals true, and dsmap replace terrain types this coordinate with terrain type.edge. Okay, so now we're checking for edges, and this is now flexible, so no matter what we do to the terrain, this should just work just fine. Okay, so sprite to spawn equals dirt. Let's see. Train type.edge. Then instead we will spawn an edge sprite. So this question mark here, this is a map accessor. So you notice here I'm saying like ds map replace, blah, blah, blah. I could do this instead. That's the same thing as ds map replace. Has a game direction been decided? No, I think the general vibe is that it's going to be something kind of Quadrupus Rampage-like, just because it's a nice blend of game loops, fairly straightforward combat and action, and level up systems. But as far as like what is actually happening in the game, I have no idea. I don't know who the character is, I don't know what you're going to be fighting, I don't know any of that stuff. Alright, so we have our sprites being spawned here. Let's see if all this works. Okay, so now we've got edges. So again, all we did was iterate over all the tiles, and for each tile, if we found an open space, then we said, hey, this is an edge. Something Rampage. Quadrupus Rampage is one of our games from 2013. So it's a 6.5-year-old game. 6-year-old game. Where you play as like a 4-limbed octopus thing fighting fish under the sea. So. Okay, so a couple things here. So this is 2 rooms on top of each other. But yeah, I mean, overall, we're starting to get there. Some of them edges, they look double wide. Yeah, so the idea here is we're just saying if any of the surrounding spaces, even diagonal-wise, are open, then we count that as an edge. So we could just not do that, but then you'd end up with kind of like the interior spaces bumping up against the edges. So okay, so we still don't necessarily have anything to do in the game just yet. We're kind of in the setup phase, but we're getting closer. So I think this is a pretty good place to end it. Let me push this. Okay, so you guys have kind of talked about getting sort of moving terrain in there where the terrain kind of moves up and down in response to stuff. That's totally something that we could do. So we can check that out next time, or maybe like when you step on it or something or land on it, then it'll kind of knock down. That'll also allow us to create shockwaves. So like if you hit something, then the terrain will kind of like ripple out, which would be great. So we need to finish world generation and then potentially get some stuff to spawn in the world. And we may also look into converting this into an isometric grid. So instead of this rectangular grid, we would use the diamond shapes, which kind of creates a little bit more of a dynamic feeling. So we could go a lot of different directions with this. So it's going to kind of come down to just whatever you guys want to see. So I'm going to try to stream next weekend, and I'll put up an event on the page once I know for sure what's happening. So just make sure to follow the channel if you want to get notified about those. And this will be up on YouTube as well, so if you missed anything and you want to rewatch or whatever, then I'll make sure to get that up. So, all right, that's it for today. Thank you very much, guys. See you next time.